All right, here we go, decomp day. All right, so when we look at decomposition reactions, if you think about just what decomposing is, decomposing, that just means breaking down. And that's really what we're looking at here, all right? So if we start with orange juice with pulp, which, by the way, is gross, all right? And we get that to just straight up pulp-free orange juice, just the juice, no pulp here. And we actually take the pulp out, remove the pulp, then we got delicious. I think that's how you spell it, right? You may or may not agree, and that's okay. All right, so decoms. Opposite of the synthesis reaction, because if you remember synthesis, that was A plus B yields AB. So this stuff is just the opposite of it. We start with a reactant, and it breaks down into two products, okay? These are often going to be elements. So what you're going to see is just a single, for us, whoops, sorry. You're going to see just a single capital letter. All right, and that's it. That will be there. Now, A and B don't have subscripts of the reactant. So if it was like AB3, we don't go A plus B3. All right. Now, there's this concept of a sneaky seven. All right. A sneaky seven, what that means is that some of our gases and iodine, which is a solid at room temperature, are what we call diatomic, meaning that they are so reactive that they exist not as N, but as N2, meaning they have to pair up with each other to be stable, okay? And again, we're not going to predict reactions. We just got to be able to see them, all right? So if we look at how lithium does this, right? So if we take lithium and turn it into lithium plus fluorine, all right, here, again, that's one of those sneaky sevens, just like this, just like this, just like this, just like this, and just like that one. All right, those are all sneaky sevens. Now, when we look here, right, that lithium is always going to be a +1. Now, in this top part here, like you can see, everything here is a -1. That's because this is all in group 17, right? This is group 16. So this is a -1 column. This is a -2 column. This is group 15, which is a -3 column. And notice we don't take the 2 and put it below the lithium. We don't take the 2, put it below lithium. All right, don't take the 3, don't take the 3. All right, all we're going to do is just write it as it is. The weird thing about this is that basically this non-metal could have multiples, meaning could be diatomic. Di meaning 2 atom. Okay, that's what it could be. And really, I mean, we're looking at hydrogen, we're looking at nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Those are our sneaky sevens that we have, so to speak. But here's the nice thing. You don't have to memorize those. Okay, so when we look at something like this now, and we've got calcium and oxygen, all right, so calcium is right there, and oxygen is right there, right? So calcium is a +2, oxygen is a -2. So what we see is +2, -2, so those are just 2 and 2, so that's why there's nothing there, all right? When we get over here, it's just calcium that we're going to have, and then O2, again, is one of the sneakies, and it's diatomic, all right? Get here with calcium and chlorine, all right, chlorine's right there, calcium's still right there. That's a 2, that's a 1. That's why we see this 2, this 1. That's why that 2 is down there, right? It's and this 2 is over here again because that's part of that sneaky 7, right? And it's diatomic. So if we were to look at these and try and balance them, right? So that would mean I got get rid rid of this stuff so I got room to write. All right. Okay, so CaO, CaO. I got 2, I got 1, I got 1, I got 1. All right, so I need 2 O's over here, right? So that 2 is going to go in front of that Ca, right? Which immediately tells me, all right, 2 times 1, that's where my 2 comes from there. But I also have 1 here times 2, so I have 2 calciums. So I'd have to make this 2 over here, that equal 2. Just a little 1 down there, so put that 2 in front of there. That one's balanced, all right? As I look at this one, right, 1, oops, sorry, old habit. 1, 2, 1, 2. That one's all balanced. So that one works out really, really well for us, all right? When we start getting these type now, Fe is in here, all right? Fe is going to have kind of a weird set of charges for us, but there again, we're not going to worry about that too much. In this case, Fe is a +3, sulfur is a -2. So that's where the 3, that's where the 2 come from. Over here, neither of those are sneaky 7s, so not sneakies. That's why we leave them as they are, all right? To balance it, Fe has 2, S has 3, Fe has 1, S has 1, so times 2 to get to 2, so put a 2 there, times 3 to get to 3, put a 3 there, okay? K3P, K is in a +1, P is in a -3, that's why we loop and swoop that one. Again, over on this side, they're not sneakies, so because of that, we don't have to worry about them being a diatomic or with little 2's below them, right? So we would say K has 3, P has 1, K has 1, P has 1. All right, so I'm going to multiply that by 3 to get 3. There, nothing changes anything else. That one is solid. All right, so just some more for you to look at. Again, you know, notice here, 1 compound on this side, and then 2 elements. All right. If I were to balance these quick, I'd put a 2 there and a 2 there. With a 1 there, this would be a 1s. All right, I'd put a 3 there, a 2 there, and a 2 there to balance that one. I'd put a 3 there, 1 there, 1 there if you want more balancing work. Okay, so a mix of these. All right, so now when we look at these, sorry, I don't have arrows on here. What we're going to see is this first one, we got something plus something else yields that. That's a synthesis. All right. Oop, there's our plus sign. It's after the fact, so that means we only got 1, and then 1 plus 1 over here. This is going to be a decomposition. All right. We look here again. Oh, I got 1. There's my plus sign. All right, that's going to be a decomposition. All right, look at this one. Oh, there's my plus sign. So I got 1 thing over there. This will be a synthesis. All right, to balance them, Li is 1, F is 2, Li is 1, F is 1. So times 2 to get me 2. Got to put that in front of that Li, right? So 2 times the 1, that's where I get that 2 from. So then I look at that Li, it's only got 1. So I'm going to need a 2 there. So multiply this one by 2 to get to 2. Put that 2 in front of there. All right. This one, Al has 2, O has 3, Al has 1, O has 2. First off, let's double that thing. All right, so that gives me 2 there. I'm gonna double this odd right now just because it's gonna make life better for us, I think. So I'll put a 2 there. Well, shoot, that 2 times 3 gives me that 6. This 2 times 2 here should give me 4. Well, that messes this up because this was 2. So I'll multiply it by another 2. So instead of having a 2 there, I'd have a 4 there. Well, I got 6 O's, so times 3. So that would be a 3 there. All right. Then MGS, yeah, those are all good. 1, 1, and 1. All right. 1, 1, and 1. All right. That's what we got for you. Good luck on your balancing quiz later on in the hour.